All right, last example. This one is dealing with a piecewise linear model, which you can totally do. You just have to separate your data points into two different tables and then treat it as two different linear equations. Remember that a piecewise equation is one that has like you've cut parts of graphs from other graphs and then pieced them together like a Frankenstein graph. Okay, so a research vessel is mapping the floor of the sea in a certain area. To do this, the boat travels directly out of the shore and measures the depth of the water continuously. The table shows a sample of the data collected. Explain why a piecewise linear function is appropriate to model depth as a function of distance from shore. Something that I've run into my calculator a lot with the TI Nspire is that once I've stored something into X and Y, on this same document, if I try and restore something else into X and Y, I'm having a hard time figuring out how to make that go away and how to change what I link up. So I just make a new document for every problem that I do. And it says, do you want to save this document? And I say, no, I do not. And then I'm going to add a list in the spreadsheet and just start with a blank slate. Okay. So I'm going to type in this data. And then I'm going to go ahead and store it now. I'm going to do var store link X, enter, var store Y, enter. And then now I need to enter in a graph to the next page. And then I'm going to do menu, graph entry, and I want to do a scatter plot. I just need to grab it from my vars button. Enter. I can see it right there, but it's a little bit clustered. So I'm going to do menu, zoom, fit, and now it just looks so much nicer. Okay, so if you first saw this, you might say like, hey, that looks like an exponential equation. But I'm here to tell you that it is in fact a piecewise linear function. So we can see that right here, there might be a line that kind of cuts across here that would make sense. And then here, it definitely looks very, very linear. And I would say that the fact that this part right here looks extremely linear would be your defining reason why you would make sure to do a piecewise linear equation here as opposed to a exponential equation. Okay, so we see that there's this breakup between the graph kind of at this point right here. To answer part A, there are two different and distinct linear behaviors in this relation. I would say also that there's such a clear break. Like you can point out this point right here as being the point where the behavior changes. And so such a sharp change in behavior would also clue me into using a piecewise function. If I wanted to trace this graph and figure out what that point was, it tells me that that point is this 1, 2.2. So what I'm going to do is I'm going to include this point in this table as well as in this table because this line should also use that point as a anchor, and it should also be used in this equation as well as an anchor point. Okay, so what I'm going to do, I need to generate a piecewise linear model, and I'm going to do that by using my regression equation. I'm going to do it twice, and now I'm going to manually separate this table into two separate tables. So I'm going to go back, and I'm going to erase this as being associated with X and Y. Just realize I've already used X and Y as my as a link to be stored, and so I no longer can use it. But I will go down here and delete all of the other data points. And then I'm going to go up to C and remember to repeat the 1 and the 2.2. Oh, and the 2.2 goes. And I'm going to now fill in the 1, 1.2, 1.4 in a separate table. Okay, so now I've got those two parts of my table represented as two separate tables, and now I'm going to do my regression equation for each of those. I'm going to scroll over just because I like my cursor to be there. I'm going to do menu, statistics, stat calculations. I'm going to do my linear regression, which is number 3. Now my X list is in A, my Y list is in B. It's storing my regression equation in F1, which is awesome. Thank you for doing that. Where I want my results to go. Realize that C and D are both taken up now by our second table. So I need to put it not in C, not in D, but now into column E for my results. It tells me that my M is 0.4 and my B is 1.9 for my MX plus B equation. So if I have, I'm going to do Y equals, and then I'll change it once I'm done figuring out this rest of the stuff. I've got 0.4 as my slope, so multiply it by X plus 1.9. Remember, with piecewise equations, you're going to have two separate equations here, and we need to have a specific domain in which we use this equation. And the specific domain in which we use this equation is between 0 and 1. So I'm going to do 0 is less than or equal to X, which is less than or equal to 1. Okay, so now I'm going to find my second equation, and I'm going to have to find a separate domain for that guy. I'm going to scroll over to make sure that I'm with that data that I want to calculate with. It's just a weird nitpicky thing that I do. I want to do a linear regression equation again. C is where my X list is now, and now D is where my Y list is. It's going to save my regression equation into F2, which is really nice. My results can't go in A, B, C, D, and now they can't go in E or F because that's taken up with our first regression equation. So I need to make sure to put my results in G. So it's just the next column over. And here we have our M and our B for our second regression equation. You can see our first regression equation is still there to the left. And I get 2.94x minus 0.747. And that is my second linear equation. This is going to be between the domain of 1. I can't include it, so I'm just going to do 1 is less than x, which is less than or equal to 2. And that is my regression equation. It's not in terms of D and H, so I just need to remind myself that depth is D, no, distance is D and H is for depth. So H of D is equal to 0.4 distance from the shore plus 1.9, and then 2.94 D minus 0.747. So that's my final answer. Oh, shoot, it's not my final answer because I need to have my domain. 0 is less than or equal to D, which is less than or equal to 1, and then 1 is less than or equal to strictly less than D, which is then less than or equal to 2. Okay. All right. So we are going to now move on and interpret the gradients. If you wanted to graph these, sorry, real quick while I'm thinking of it. I would need to go back and do a new graph and then do my scatter plot with A and B and then C and D. And then my two regression equations would be saved in F1 and F2. So you can definitely go in and then see it all like broken apart and see the different linear regressions. I think I could right now show you just the linear regressions without the broken up data points. Graph entry, just function, it automatically jumps to F3 because there's something in F1 and something in F2. If I scroll up on F1 and press enter, it does that. And then menu, graph entry function, scroll up to F2 and press enter, it will also graph that. So there's your two regression equations.